Okay, I want to go over the lab about using inverse trig function to solve equations. So on this lab, I'm going to go through the first few problems to help explain, how these things interact with one another. So for the first problem, we need to solve sine theta equal to 1/2. So, well, we've done this kind of problem lots of times before, and so you should know what the solutions are. Okay, so let's draw the unit circle to identify the solutions. From memorizing the unit circle, you should be aware that pi over 6 is a solution. Well, what's the other solution? You probably remember that it's going to be this one over here, which ends up being 5 pi over 6. So there's your two solutions to that equation. You just jot that thing down here. Theta is equal to pi over 6 and 5 pi over 6. However, when you were beginning to memorize the standard angles on the unit circle, you probably had a trick or two to help you to remember which quadrant the solutions were in. Well, you probably memorized what was in the first quadrant, and then you probably used a trick to remember that it was something in the second quadrant. For example, you probably remembered that for the sine function, if sine equals a positive number, then you know it has solutions on the top half, or the first and second quadrant. Something like that. So let's see if we can figure out the second one. Sine of theta is equal to 1/3. So, alrighty. Well, I haven't memorized one of these angles, but let's go ahead and see if I can draw what's going on. So, sine of theta is equal to 1/3. So, the first question we should be asking is, how many solutions are there to sine of theta equal to 1/3? And just like the first one that we knew how to solve, we know there's two solutions. One has to be in the first quadrant, and one has to be in the second quadrant, and this is because sine is a positive number. It's 1/3. Alrighty, so the first thing that probably comes to mind on how to solve this thing is to write this as theta equals sine inverse of 1/3. And that is certainly a solution. So which one is it? Is it the solution in the first quadrant or the solution in the second quadrant? To determine that, I need to remember that the range of sine inverse is just as we talked about in lecture, is negative pi over 2 to pi over 2. And so graphically what that means is that it is this half of the plane. So that means that the solution in the first quadrant, this one right here, let me see if I can draw it here. This angle right here, that angle is going to be sine inverse of 1/3. Does that make sense? So, so now that we know that that's one of the solutions, and that's what that angle is. Now remember, sine inverse of 1/3 is just a lot of symbols to represent a number. So this is some number of radian, in radians, some angle. So now how do we figure out the solution that is in the second quadrant right here? Okay, well, maybe I should restate that. How do we figure out this solution right there? Well, something that I notice is that this little angle here is the same angle that's in the first quadrant. So that little angle is also sine inverse of 1/3. And I know that right here is pi, and this little angle here is sine inverse of 1/3. So my solution in the second quadrant, the blue angle, has to be pi minus sine inverse of 1/3. Cool? So the solutions to this guy are going to be theta equals sine inverse of 1/3 and pi minus sine inverse of 1/3. Cool? So I'm going to box that. There you go. And those are my solutions to that one. Let's try another one. Let's try cosine. So the one on the left is one that we already know how to do. Cosine theta is equal to negative square root of 2 over 2. So to draw this, cosine of theta is equal to negative square root of 2 over 2 right here. And where's the other one? Well, we recognize that it's over here because I know that cosine is negative on the left side and is positive on the right side. So this angle here is going to be 3 pi over 4, and this angle here, well, that's 5 pi over 4. So the solutions to this guy are 3 pi over 4 and 5 pi over 4. And if I didn't memorize that, well, then I could remember that it's in these two quadrants and it's a pi over 4, so it ends up there. So the other one, cosine theta, is equal to negative square root of 5 over 3. Well, now I don't know what the angle. I don't know what the solution is for this by just looking at it by my standard values. But I do know that cosine is negative. So just like on the first one, I know I have to have a solution over here, and I also know I have to have one in the third quadrant because that's where cosine is negative. Make sense? Alrighty. So by looking at this, I can determine that one of the solutions are going to be cosine inverse of negative square root of 5 over 3. Okay. Sorry, let's fix the plus sign where it should be. So, and which one of these two angles is that number? Cosine inverse of negative square root of 5 over 3. Again, that's a number. It's a number in radians that tells me what, that is one of the solutions to this thing. You can plug it in your calculator and you can figure out what the decimal approximation is. So which one of these? Is it quadrant 2 or quadrant 3? Well, because the range of cosine inverse is 0 to pi right there, the range of cosine inverse is the top half. I know that cosine inverse has to be that angle. So I know that that angle is cosine inverse of negative square root of 5 over 3. The reason is because I know my solutions have to be in quadrant 2 and quadrant 3, and the cosine inverse has to reside within its range, so it has to be the top one. Okay, so now that that one's figured out, let's see if we can figure out the second one. Let's figure out this angle right there. Okay, so to figure out that angle, I notice that this angle down here is also cosine inverse of negative square root of 5 over 3. And so, but that one, this one is going to be the negative angle. So since that one is negative, cosine inverse of square root of 5, negative square root of 5 over 3, that means that the the purple one is going to be 2 pi plus that guy, or 2 pi minus. Well, 2 pi plus the blue one, which is going to be a negative square cosine inverse of square root of 5 over 3, as it's written there. So those are my two solutions. That guy and that guy. Make sense? Okay, so let's go ahead and look at problem 3. So if sine is a number that is positive, so again, let's look at this. If sine is a number that is positive, remember, sine is positive on the top half and negative on the bottom half. Then sine inverse is in, and this is asking for where sine inverse resides. Sine inverse is going to reside in its range, and that's what I drew. Sine inverse's range is negative pi over 2 to pi over 2. So if sine is positive, then sine inverse lives in quadrant 1. It's this one right there, because that is the overlap of positive and range of sine inverse. Okay? So if I have an equation, sine of theta equals y, the sine inverse solution will be in quadrant 1. So by deduction, my second solution has to be in quadrant 2. So this one's going to be in quadrant 2. Similarly, if it's negative, the sine inverse one has to be the negative one in the range of sine inverse. So that's going to be quadrant 4. And then the other one is going to be in quadrant 3. Something I want to point out, though, is that quadrant 4, because the range of sine goes from negative pi over 2, the range of sine inverse goes from negative pi over 2 to pi over 2. This quadrant 4 will have negative values in it. So you may have to add 2 pi to it to get a solution from 0 to 2 pi. Doing the same thing in terms of cosine, so again, where is cosine positive? Cosine is positive in the first and fourth quadrant. And where does cosine inverse have its range? It has its range on the top half. Okay, and so here it's negative. I'm just drawing that. So cosine inverse, when it is positive, the cosine inverse will reside in the first quadrant, right there. Quadrant 1. And so if it's positive, it will have a second solution, and it will reside in quadrant 4. So this is going to be quadrant 4. And when it's negative, cosine inverse is going to be in the second quadrant. So that's quadrant 2. And the other solution is going to be in quadrant 3. Okay, so now looking at the tangent values, we're going to do the exact same analysis. I know that the range of tangent goes from negative pi over 2 to pi over 2, similar to sine, and tangent is positive in the first quadrant. It's also positive in the third quadrant, and it's negative in the other two. So the tangent inverse, when it's positive, will again be in quadrant 1, but when it's positive, the other solution is going to be in quadrant 3. Whereas when it's negative, the tangent inverse is going to be in quadrant 4. When tangent is equal to a negative number, the solution that is tangent inverse will be in quadrant 4, and the other solution will be in quadrant 2. And again, this guy are going to be negative values, and so you're going to have to add 2 pi to it to get it within 0 to 2 pi. I hope that helps, and go ahead and contact me if you have any questions.